And now for podcast number 25. This is the cube root function, or in other words, it's y equals x to the 1/3. And just like in podcast number 24, we're going to need to know the arc length, so we might as well find the derivative. Using the power rule, the derivative is going to be 1/3 x, and then subtract 1 from the exponent, which is going to leave negative 2/3. And because it's being rotated about the y-axis, that means that the radius, so the graph, let's see, it goes through, it's going to look something like this. It would go down here also, but from 0 to 1, it would look like this. And then since we're rotating about the y-axis, then the radius would go from here to here. And then that means that the radius is equal to x. So down here is some x value. And then when we put the limits of integration, having it go from 0 to 1, then that's going to have the x start here and then eventually move over to 1. So the arc length is going to be the integral from 0 to 1. There is the 2 pi. There's the radius, which is x. And then we need the arc length, which is the square root of 1 plus the derivative is squared. And I forgot my 1/3, so let me just write the x part and then times 1/3. Okay. Now we need to do algebra here, so we need to square this. So when you have x raised to an exponent and you square it, that means you actually multiply it by 2. So this little fraction up here is going to become a negative 4/3. And then this is going to become a 1/9. So there's square root, and it's going to be 1 plus. Okay, I'm going to move the fraction. Actually, what I could do is just, this has a negative exponent, so that's going to go to the bottom. This is already in the bottom, and then square it, so that puts a 9 in the bottom. And like I said, when you raise a power to a power, you multiply. So this is x to the negative 4/3. But then if I don't use negative exponents, that means that x to the 4/3 goes in the denominator. And then this 1 can stay in the numerator. And then we need to do some more algebra. In order to add these two things, we need a common denominator. So this 1, you could rewrite it as, I think I'll just go to the next step and do that. So this 1, you could rewrite it as 9x to the 4/3 divided by 9x to the 4/3. And right now it looks like it's going to be a very long mess, but the algebra actually works out pretty nice. So just keep going. Persistence will pay off. And with this square root, we've got a 9x to the 4/3 plus a 1, that's the numerator. And then the denominator is the 9x to the 4/3. So I'm going to take the square root of the top and square root of the bottom. So there's the square root of the top. That cannot be simplified because of this plus. But on the bottom, you can simplify. The square root of 9 will be 3. And then when you take the square root of this x to the 4/3, it's going to cut that fraction in half. So it's going to be 2/3. So x is to the 2/3. And then we could do a little bit of simplifying, like for example, this x to the 2/3 on the bottom and this x on the top. Well, this is x to the 1. And if you're dividing, that means subtract the two exponents. So a 1 minus a 2/3 will be a 1/3. So there's going to be x to the 1/3. And then I think at this point I'm going to move the constants to the outside. So the 2 pi over 3, I'll just factor that out. And then we've got this simplified, and we've still got the square root. And then how are we going to integrate this here? Yes, you're right. U substitution is the way to go. So we let u equal the inside part. So the u equals what's inside of the radical, 9x to the 4/3 plus 1. And then take the derivative of that. So du will equal, so take the 4/3, bring it in front and multiply. So 4/3 gets multiplied with 9. And then subtract 1 from this exponent. And 4/3 minus 1 will be 1/3. And then the derivative of 1 is 0, so that's gone. And then we've got the dx. And the only way that u substitution works is if this is showing up in the problem. And it just so happens that this is showing up in the problem. So we do need to simplify this and move these numbers to the other side. So simplifying means that 3 will divide into 9 3 times, and then what's left is 4 times 3, or 12. So multiply both sides by 1/12. So we'll have 1/12 du is equal to the x to the 1/3 times dx. So the x to the 1/3 and the dx are going to get replaced with just this 1/12 du. And then this is going to get replaced with u, leaving only the square root of u. So I'll continue over here. So the 1/12 needs to be factored out. And then we already had the 2 pi over 3 that got factored out. So just transferring this part. And it says integrate from 0 to 1, but that is what x equals. Right now I'm going to have u, so for the moment I'm going to leave off the numbers 0 to 1 until I get back to x. So the 1/12 and the du, that's going to replace the 1/3 x to the 1/3 dx, so that's done. And then this will become the square root of u. And what can we do to simplify? Let's see, a 2 will divide into a 12 6 times. So on the outside, that's going to leave pi over 18. And then the square root of u, you could rewrite that as u to the 1/2. So when you integrate, add 1 to the exponent, will be u to the 3/2. And then divide by 3/2. And I know that when you divide by 3/2, that's the same as multiply by 2/3. So now we're done with the integrating part. We just need to replace the u and then replace the 0 and 1 for x. A little more simplifying, a 2 will divide into an 18 9 times. So that's going to leave pi over 9 times 3, or pi over 27. Replace the u with this 9x to the 4/3 plus 1. And then it's raised to the 3/2 power. And now that I'm back to x, now I can put the values for x, 0 to 1. And after all of that work, I'm very glad that we have 0 and 1, because substituting a 1 is not going to be very difficult, because this will be 1 raised to the 4/3. So that means it's 9 plus 1. So we've got our pi over 27. And then when you substitute 1, this will be 9 times 1 plus 1. So that's going to be 10 to the 3/2 minus, and notice that I just factored out the pi over 27, so I don't have to carry it around over here. So when I substitute a 0, this is going to be 0 times 9, so that's gone. All that's left is a 1. And then 1 to the 3/2 is just 1. So you could say that the answer is pi over 27, and then 10 to the 3/2 minus 1. Or if you want to know what number that is pi divided by 27 on the outside of the parentheses. And then, okay, that's a little bit too dark. And then 10 is raised to the 3/2, and then minus a 1. So that is 3.563. And then there it is, 3.563.